And ladies and gentlemen, here we go. Geometry Chapter 8-3, Special Right Triangles. So, let's look at this right triangle. Okay, here we have the right angle. Notice that both of the legs are the same length. So, if we use the Pythagorean theorem to find this other side, okay, 1 squared plus 1 squared equals c squared. So 1 squared is 1. So 1 plus 1 is c squared, so 2 is c squared, and the square root of that is just the square root of 2. So if I have 1 here, 1 there, I have the square root of 2. What about if I make this 2? Well, similar situation, so I now have 2 squared plus 2 squared is c squared, so 4 plus 4, which is 8, equals c squared. So the square root of 8 equals c. Now 8 is 2 times 2 times 2. Okay, so if I want to write that in radical form, here's a pair, a perfect square, so I can pull this out. So then I have 2, and the square root of 2 is equal to c. So that's 2 times the square root of 2. Notice on the previous screen, we had only 1 time the square root of 2. Now it's 2 times the square root of 2. Notice there's a correlation between the length of the legs and the factor here. So also, because these two legs are the same length, we know that these angles here have to be the same. And if this is 90, that leaves 90 for these, so these are each 45. Okay, that's the first special triangle we're looking at, the 45, 45, 90 triangle. In a 45, 45, 90 triangle, the length of the hypotenuse is the length of a leg times the square root of 2. The hypotenuse is a leg times the square root of 2. So if I want to use that, find x. Right here, we know this is a special right triangle, right angle, 45, so this is also 45. If the leg is 6, the length of the hypotenuse is the square root of 2 times 6. So there we go. That was pretty easy. If I know the length of one of the legs, 9 times the square root of 2 times the square root of 2 is 9 times 2, which is 18. Or here, if I know the hypotenuse, and I want to find one of the legs. Same formula, hypotenuse is a leg times the square root of 2. Just this time, I know what the length of the hypotenuse is. So I plug that in, and then divide by the square root of 2. And so x is 12 over the square root of 2. Now, remember, you don't want a radical in your denominator, so we're going to get rid of that by multiplying and then simplify. We get 6 times the square root of 2. Alright, the other special right triangle that we're looking at is the 30, 60, 90. 30, 60, 90 has special special attributes where the shorter leg, okay, we have two legs, one's the shorter leg, the longer leg, and the hypotenuse. You take the shorter leg times 2 and you get the hypotenuse. And then the shorter leg times the square root of 3, and that's the longer leg. Okay, so the hypotenuse is 2 times the shorter leg, and the longer leg, L for the longer leg, is the square root of 3 times the shorter leg. Okay, so here we know this is 90 and this is 60, which means this has to be 30, so there's a special right triangle. So there's the shorter leg. Okay, the longer leg, we remember, is the shorter leg times the square root of 3. So I'd have to divide by the square root of 3 and then get rid of that square root in the denominator. Divide by 3, we have 5 times the square root of 3, and we know the hypotenuse is twice the shorter leg. So 10 times the shorter leg. And there you go. That's all there is to special right triangles. That was Chapter 8.3. And remember to like and subscribe to the Mastermind channel.